Hello everyone, welcome to MindMatrix. So in this video, we will be solving questions of digital logic from Set-2, GATE 2024. So let's start. So this is my introduction. My name is Anshul Sharma. I'm upcoming software engineer too at Juniper Networks. Currently, I'm pursuing MTech in computer science from IIT Kanpur. I have 2+ years of experience, mentored more than 1,000 students as of now, and I have the expertise in computer science and data science subjects. Secured All India Rank 294 in GATE Computer Science, cleared ISRO and IC NEET exam. Also got selected as Administrative Officer at AIC. These are our premium courses. So that is for GATE CSE Complete Course 2025-2026, GATE DA Complete Course 2025-2026, and we are also providing both the packages for GATE CS and GATE DA as a combo as well. So you can start enroll in the course and start your preparation for GATE 2025, or if you're preparing for 2026, then also you can start your preparation now as early as possible. So you can visit our website www.mindmatrix.net.in. Live classes have started already, and we are providing, you can just read it out, we are providing a lot of things in these courses. Not just the obviously top-notch quality content will be there, but apart from that, placement preparation course also we are providing, test series we are providing, practice questions we are providing, one-to-one mentorship we are providing. So a lot of things are there, and that too at an affordable price. Okay. So fees is affordable so that every student can afford, and they can prepare well. Okay. So yeah, so if you want to check the content quality, you can enroll in this operating system course that I have started. Okay, I'm teaching live, so you can attend the live classes, or you can watch the recorded classes, whatever we have covered so far, and that is too for free. So you can enroll in this course. All the links are given in the description. You can just click on it and you will be able to proceed further. So you can visit our website for more details. You can also connect with us. This is our public doubt discussion group, MindMatrix Official. You can join this group by scanning this QR code, Telegram group, and you can also join our WhatsApp channel. And this is the QR code for our website. Fine, so let's start. This is the first question we have. Let's read the question first. The format of a single precision floating point number as per the IEEE 754 standard is this. So we know that IEEE 754 single precision format is this only, that 1 bit is assigned for sign, 8 bits are assigned for the exponent, and 23 bits are assigned for the mantissa part, right? We have to choose the largest floating point number among the following options. So 4 options are given, as you can see here, and among these 4 options we have to find the largest floating point number. So in order to find the largest floating point number, see, exponent has to be the highest. 8 bits are there for exponent. So if we have, let's say 1 2 3 4 5 6 7 8, if let's say these are our 8 bits of exponent, that means all ones. So there are 2 cases in case of single precision format. If e is equal to 255, because if you have all ones, that means 8 bits to 2 raised to power 8 minus 1, maximum value of exponent can be 255. If you have the exponent as 255, then there are 2 cases possible. First case, when m is equal to 0, and other case when m is not equal to 0. When m is equal to 0, that will represent, so there is a reserved representation, that is for infinity. See, infinity is not a number, it is just a representation of very huge number, and we cannot say it is a number. It is just a representation that is reserved in case if e is equal to 255 and m is equal to 0. In that case it is reserved. If m is not equal to 0, then clearly we say that it is not a number. That means it cannot be represented. It is not a number, that does not exist. Okay, so we need to find the largest. So obviously we cannot have when we are talking about largest floating point number, we cannot have all ones in the exponent. So what else we can have? The smallest, just smallest to this one will be 4 times 1, then 3 times 1, and then 0. Definitely this is going to give us the largest floating point number. So this is going to be the value of exponent. And what about the mantissa? Mantissa, if you are having all ones, 23 ones, definitely this is your largest number. But now let's see the options that we have, because in the options we have to choose, right? So if you see option A, here we have 0 bit for sign, fine, and this is the exponent given to us. And here it is, in the beginning we have 0 and then all ones. If you see option B, we have all ones and then at the end we have zeros. 0 1 0, right? And then if you see option C, all ones are there. Definitely here E value is 255, and if you talk about mantissa, all ones are there, that means it's not equal to 0. So this represents not a number. This represents not a number. Now we have to compare, in these three options A, B and D. So definitely this is going to give me the largest floating point number. Why? Because if you compare the exponents here, you have 0, then all ones. So definitely this is the smaller as compared to this, right? So, and here if you see also, this is also smaller. So definitely D cannot be the answer. Option C already we have eliminated. Option A is also not possible. So here we have all ones in the mantissa, and we have the maximum value that we can have for exponent, because in case of 255, these are the two cases that exist. So this is going to give us the largest floating point number when all ones are there, and in the exponent we have 7 ones and 1 0. Is it clear to all of you? So option B is the correct answer for this question. Let's proceed to the next question. This was very easy question. Okay, if you have studied floating point number, it was a really easy question. Let's see this question now. Again, a simple question. For a Boolean variable x, when you say Boolean variable, that means it can take either 0 or 1. Two values possible, either 0 or 1. Which of the following statement is or are false here? So option A says x and operation. So this dot represents and operation, right? And operation. So x and 1. Are you going to get x? Yes. Why so? It is simple. Just I'm giving you a further explanation. Let's say x value is 0 because it is a Boolean variable. What will be the result? Result will be 0 because you are performing AND operation. In case of AND, if any one value is 0, the result will be 0. If let's say x value is 1, in that case 1 and 1 will give you 1. Now all are 1s, so the result will also be 1 if you are performing AND operation. So ultimately, if you see, the result depends on the value of x. The result depends on the value of x. So definitely this is correct. So this is true. This is true. Now what about option B here? X or 1 is equal to x. X or 1 is equal to x. You are performing OR operation with 1. If you take x is equal to 0, so 0 or 1 will give you 1 only, right? You perform OR operation with 1 and you take any other value, result will be 1 only. If you take 1 x as the value of x, so 1 or 1, still it is 1. OR operation, right? So in case of OR, if any one input is 1, output is going to be 1. So ultimately, it does not depend on the value of x, because here it is 0, result is 1. So definitely this is false. These are very basic things, but still I'm giving you the explanation so that if you have any misconception, it should be clear. It should get clear. X and x is equal to 0. Is it true or false? If I'm taking value of x as 0, 0 and 0, definitely it will give me 0. But if I'm taking the value of x as 1, 1 and 1, will it give me 0? No, it will give me 1. That means this is incorrect. This is incorrect. This is false. What about option D? X or x complement is equal to 1. If I take x value as 0, complement of that is 1. So 1 or 0 is 1 only. If I take this as 1, this is 0. So still it is 1. So definitely it is true. Clear? And we have to find which one is false. So option B and option C. BC is the correct answer for this question. Clear? Let's proceed to the next question from number system. So which of the following is or are? So it is MSQ again. Equal to 224 in Radix 5. That is base 5 notation. So this is given to you 224 in base 5, and you have to find out of all these 4 options which one is equivalent to this. It is very simple. See, in the options it is given that option A in Radix 10 decimal, option B is in Radix 8, Radix 16, Radix 7. So it's better to convert everything into decimal. If you convert this into decimal, 2 into 5 square plus 2 into 5 raised to the power 1, 4 into 5 raised to the power 0. This is how you convert in decimal, right? So this will give you what? This is 25 into 2, that is 50. This is 10, and 5 raised to the power 0, 1, that is going to give you 4. So this is equivalent to 64 in base 10. So definitely option A is the correct answer. I'm sorry. What about option B? Convert that 2 into decimal. So that is 1 into 8 raised to the power 2. 0 into 8 raised to the power 1 plus 0 into 8 raised to the power 0. So ultimately you are getting 64 in base 10 only. This is also equivalent. What about option C? 50 in base 16. So 5 into 16 raised to the power 1 plus 0 into 16 raised to the power 0. This will give you what? This becomes 0 and this is going to give you 80. 16 5 is 80, so 80 in base 10. So this is incorrect. Option D, 1 to 1 in base 7. So 1 into 7 raised to the power 2, 2 into 7 raised to the power 1 and plus 1 into 7 raised to the power 0. So what do you get? This is 49 plus 14 plus 1. You will be getting again 64 in base 10. So option D is also correct. So A, B, D is the correct answer for this question. Fine. Let's proceed to the next question now. Consider a 4 variable functions f1, f2, f3, f4 expressed in sum of minterms form as given below. So f1 is given to you, f2, f3, f4. The minterms, sum of minterms, given for all these functions. Now, with respect to the circuit given above, which of the following option is or are correct? Again, MSQ question. More than one may be correct. Right. So multi-select question. Now, let's try to solve it. So basically, we have to answer in terms of minterms and maxterms. Right. Sum of minterms and maxterms. So it is simple. F1, F2. Here we have the AND gate. Here we have the AND gate. So when you are performing, let me use another color here. Okay, so just a minute. Yes, so let's talk about F1 and F2. Here we have the AND gate. Right, now minterms for F1 are given to us, minterm for F2 are given to us. Minterm represents that the value is 1. For those combination of variables, the value is 1. Right, that means for F1 0, that means A complement, B complement, C complement. In terms of 4 variables, so D complement, the value is 1 for that. Right, so basically minterm represents the value is 1. So, and we are performing AND operation, so definitely output will be that which is common between, basically if you see here, you are performing AND operation. We know in case of AND operation, 1 and 1 will give me 1 only, right? So let's say this is your minterm and this is your minterm. This is the minterm for F1, this is the minterm for F2. You are performing AND operation and you are getting output as 1. So when you are performing AND operation between F1 and F2, in the output you are going to get only those terms which are present in both, right? So here if you see 1 is not there, 3, yes, 3 is common, 5 is common, 7 is common, 11 is common, 13 is common. These terms are present in both F1 and F2. So we are performing AND operation. So definitely we will be getting 3, 5, 7, 11 and 13. So here we got the output of this first operation that we are performing between F1 and F2. Because we are going to get only those terms which are present as a minterm in both the functions. Clear? Now what about this OR operation? You have F3, you have F4, and there is OR operation here that you are performing between these two functions. In OR operation, when we are performing OR operation, it doesn't matter, like let's say 1 or 0 will give you 1, 0 or 1 will give you 1. That means whether, like, whatever terms are present here, just a minute, whatever terms are present here in F3 and whatever terms are present here in F4, if you are performing OR between them, all the terms will get included. Because if these are minterm represent 1 in the output, right? So the OR operation between these two will give you 1. Clear? So you have to consider, in case of OR, you have to consider all the terms present in F3 and F4. So what do you get here? So you will be getting a 0, 1, 2, 4, 6, 11 and 13. This is what you are getting here. Now finally you need to perform XOR between these two, the outputs of these two. You have to perform the XOR. Now what does XOR mean? Let's try to understand. When I'm performing A XOR B, it is nothing but A complement B or A B complement. That means we have the in the output we will be getting those terms which is present either in A, right, or in B, and but they are not common, they are not common in both the functions. So basically in the XOR we are not getting AB means common in both. Either it is present in B or it is present in A. Either it is present in B or it is present in A. That means either it is present in this term or it is present in this term. Clear? That will be in the output. And except the terms which are common. That means if some terms are common between this one and this one, that will not be in the output. That you are not going to get in the output. Clear? Either it is present in this one, as you can see, A XOR B. Either it is present in B, either it is present or it is present in A. Because here it is A complement, here it is B complement. Only those terms will be present in the output, final output. So if I talk about the final output here, I'm writing. So as you can see, 0 is present here, but here it is not present. So definitely 0 will be there. 1 also will be there because 1 is present here, but it is not present here. 2, similarly 2 will also be there. 3 is present here, but it is not present here. So that will also be included in the output. Same for 4 and 5, 6 also, 7 also. But if you talk about 11 and 13, it is present in both. So that cannot be in the output if you are performing XOR operation. I told you the reason also. So this is going to be the set of minterms that you are going to get. We also have to find the maxterms. So it is very simple. The terms which are not present in the minterms will be your maxterms here. So 0, 1, 2, 3, 4, 5, 7, 8. So 8 will be there, 9, 10, 11, 12, 13, 14 and 15. All the terms which are not present in the minterms, that means those are your max terms, because here we don't have the concept of don't care. Don't cares are not present. Only minterms and max terms they are talking about. So max terms are these and these are your minterms, sum of minterms. So if you see the options, option A says 0, 1, 2, 11, 13. Definitely this is not correct. If you talk about max terms, so it is 3, 4, 5. No, that is also incorrect. Minterms 0, 1, 2, 3, 4, 5, 6, 7. Yes, this is correct. So option C is correct. Option D, 8, 9, 10, 11, 12, 13, 14. Yes, this is also correct. So C, D is the correct answer for this question. I hope it is clear. It was also a simple question. So that's it from the set 2 of digital logic subject. Right. Now in the next video, we will be solving questions from another subject. And that's it. You can join our Telegram group. If you have any, doubt, or if you need any guidance, then also you are most welcome. You can join our WhatsApp channel also, and don't forget to visit our website www.mindmatrix.net.in. If you want to enroll now, so you can apply this RISE 30 code that will give you 30% off on all our premium courses, and this is valid till 25th of Feb. Fine. Okay, so that's it from my side. I will see you in the next one. Till then, take care and bye bye. Thank you. And do like and share and subscribe to our MindMatrix YouTube channel. Bye bye.